Hello, Assalamu alaikum. Welcome to this third lecture of Chemical Industries Grade 10th Chemistry. And since we have already uploaded two lectures regarding chemical industries, and this is third one, and I would like to bring this information to your kind information that this is simple video. Please use this video only for help and use earphones. So in the first two lectures we are done with 16.1.1 SLO, that is relate the study of chemistry to careers in industry, and the second SLO is also done, in which we have described metallurgical operations. We have defined metallurgy, we have defined different terms which are used frequently in metallurgy like minerals, ores. So this video is about extraction of metal, and specifically we will be talking about iron, right? Extraction of iron is our today's topic. And you know that first we have got this ore. uh, let's suppose this is an iron ore, right? So you have got this ore. What you did in the first, like you did purified, right? You concentrated this ore. And what does concentrate means? The concentration of ore is the process in which we purify, we eliminate the gangue particles. What are the gangue particles? Those are unwanted particles which we do not want, those particles. So we have eliminated those particles as much as possible, and that was concentration of the ore. So we purified somehow the sand, mud, and the clay. Those type of particles or gangue is being removed from the ore, and we are left with metal compound. We are left with metal compound, and specifically from this metal compound we have to extract metal, right? We have to extract metal. We have got a compound and we need to extract metal from it. And what's the metal? The metal is iron in our this example, or according to RS law. We are going to do what? We are going to do the extraction of iron metal. So that is the third law according to Afghan Examination Board and Chemical Industries. So steps for extraction of metal. Alright, these are steps, and I'm not going in detail. And okay, the first SLO of today's lecture, to describe the extraction of metal, we have to describe the extraction of iron, right? So this is the SLO, and I have jotted some sample objectives for this SLO. So on these objectives we will be working, and this is what a Khan examination board expect from each student to know in this SLO. I'm repeating, what a Khan examination board expect from student. Khan examination board expect from student these objectives to be covered in this SLO. The first objective which you should be able to know after completion of this SLO, that is highlight the impact of chemical reactions with reference to thermal changes that occur during the extraction of iron, build connections between the stepwise reactions occurring in the blast furnace, stage-wise extraction of iron from the raw materials, the purpose of each raw material and its utilization in the process of making the product, producing or oxidizing reagents. I am moving towards the extraction of iron. So you have got iron ore, you completed concentration of iron ore, you have got a blast furnace is used for extracting iron from its ore. It is an oven shaped like a chimney, at least 30 meters tall. And then you have iron ore. First of all, you should have iron ore. What you are going to put in this furnace, what you are going to put into this furnace is that you should have three things. The first thing is iron ore. You will be putting iron ore from the top. Secondly, you will be putting limestone. And the thirdly, you will be putting coke. It means you have got three reactants or three things which you need in this process, or which you will be putting into your furnace, right? So what's in the charge? Charge contains three things that I just discussed: iron ore, limestone, and the third coke. So charge is the combination of iron ore, limestone, and coke. So iron ore can be any iron ore, but in our example, we have taken hematite, right? You can have any other iron ore. There are 4 to 5 iron ores which are used for extraction of iron ore, but hematite is iron ore which we use mostly, right? It's mainly iron oxide. So what's the formula of iron ore? Hematite, that is Fe2O3, and limestone, you know, that is calcium carbonate, CaCO3, and the coke is almost carbon, right? Coke is almost carbon. So hot air is blasted in through the bottom. What you do, you put those things, the iron ore, that is hematite, and the second limestone, and the third coke. You will put those things into the furnace. You use hot air from the bottom. From bottom, you what you do, you use hot air. Hot air is blasted in through the bottom. After a series of reactions, liquid iron collects at the bottom of the furnace. Now from this slide onwards, very important reactions I'm going to discuss, and these reactions are very important, right? The reactions in the blast furnace, reactions, products, and waste gases. Okay, now you have to concentrate on this. The first stage, what is going to happen in blast furnace? The first step, the first stage that is going to happen, the coke burns. As I already told you, you have got coke, limestone, and iron ore, and specifically you have got hematite in iron ore. So the first stage that is going to happen is the coke burns, giving off heat, right? The coke which you have put it into the blast furnace, that is going to burn, and that will give you heat. The blast of hot air starts the coke burning. It reacts with the oxygen in the air, giving carbon dioxide. So this is the first reaction that is going to happen. The coke is going to burn. So coke is going to react with oxygen to make carbon dioxide. This is coke. As I said, coke is simply carbon. So carbon will react with oxygen, and then as a result, in product, you will get carbon dioxide. This is the first step. And the second step, the second stage, is carbon monoxide formation. In second stage, the carbon monoxide will be formed. The carbon dioxide reacts with more coke, carbon dioxide. This carbon dioxide, which is already formed in the stage 1, that is going to react with more coke. So as a result, carbon monoxide will be formed. So you have got carbon and the carbon dioxide, which is already you have in the blast furnace as a result of stage 1. So carbon dioxide and a carbon will react, and you get carbon monoxide. And this is what we have studied till now, the stage 1, in which coke burns, carbon plus oxygen, and as a result carbon dioxide is formed. In stage 2, carbon monoxide is made, and carbon plus carbon dioxide both combine and carbon monoxide forms. These two stages are being discussed up till now. Now the comments are important. Comments are very important as per your syllabus and the way questions are asked in Afghan examination board, because these comments are important for your MCQs, right? Based on these comments which I have shown here, MCQs will be asked, right? And in later or by the end I will be discussing some MCQs as well, what type of MCQs will be asked from this SLO. So comments are like the first stage in which carbon dioxide is formed. First, coke and oxygen reacted. As a result, carbon dioxide is formed. I will mention comments of the first stage. What was first stage? That was formation of carbon dioxide, and how it was just the reaction of coke and oxygen. So this, like all combustion, is a redox reaction. The first stage was a combustion, and combustion is redox reaction. This is something you have to memorize, and you have to think which is oxidized and which is reduced. The carbon is oxidized to carbon dioxide. Which is oxidized? Carbon is oxidized to carbon dioxide. The blast of air provides the oxygen for the reaction. The reaction is exothermic. It uses off heat, which helps to heat the furnace. In this redox reaction, the carbon dioxide loses oxygen. This is the second stage I am talking about. In this redox reaction, what was second stage? Do you remember? The second stage was the formation of carbon monoxide, in which carbon dioxide was reacting with coke. The carbon dioxide reacts with more coke and it gives carbon monoxide. So this was the second stage, and I'm mentioning the important things happening in second stage. In this redox reaction, the carbon dioxide loses oxygen. Carbon dioxide it's also a redox reaction, something you have to memorize, and the carbon dioxide loses oxygen. It is reduced. You see here carbon dioxide, what? Carbon dioxide loses oxygen. So here this carbon dioxide is going to lose oxygen, and lose of oxygen is what? Lose of oxygen is reduction. So lose of oxygen is reduction. So that is why carbon dioxide is reduced, because it has lost oxygen. So oxygen is lost by what? Carbon dioxide. So carbon dioxide has got oxygens here, but it will lose, and it will gonna reduce, right? The reaction is endothermic. It takes in heat from the furnace. That's good. Stage 3 needs a lower temperature. Okay, this reaction is endothermic. The first stage was exothermic and second stage is endothermic. So this is it all about stage 1 and stage 2. I have displayed everything, the reactions as well as comments. So pause the video, read it and jot these points. And the third stage, the final stage, what happens here? The first two stages are discussed, and now we are moving to stage 3. The iron oxide is reduced. What is this iron oxide? Is simply the ore, right? This is hematite. This is hematite. So hematite and it's iron ore. So iron ore, we have taken hematite, right? So iron ore can be anything, but in our example we have taken hematite. So this is where the actual extractions occur. This stage 3 is very important, where actual extractions occur. Carbon monoxide reacts with the iron ore. Carbon monoxide, you have got carbon monoxide. What is the formula of carbon monoxide? That is CO. CO is what? That is carbon monoxide. So it is going to react with iron ore. It is going to react with what? Iron ore. And specifically you have taken hematite iron ore, right? So that carbon monoxide is going to react with hematite, and the formula of hematite is Fe2O3. So once they react, giving liquid iron, so you get liquid iron and carbon dioxide as a product. The iron trickles to the bottom of the furnace. So iron that will deep go down at the bottom of the furnace, it will settle down. Now I would like to mention comments of the third stage, that was basically actual extraction of iron, where iron or hematite was reacting, right? Reacting with carbon monoxide. As a result, we got iron and carbon dioxide. So what are the comments of that stage 3 is in this redox reaction. The first thing, that is redox reaction. In all of the three stages, we have noted that the redox reaction is something that is a common reaction happens, that is redox reaction. Carbon monoxide is the reducing agent. Here, which is reducing agent? This is something you should know, because this is something a QEB asks in MCQs, that carbon monoxide is the reducing agent. So carbon monoxide, in this reaction, the carbon monoxide is what? Reducing agent. It is going to reduce others. सही है? So it is going to reduce others. So it will reduce the hematite. So hematite is going to be reduced. It reduces the iron oxide to the metal. It is going to reduce the iron oxide. Is iron oxide is what? That is simply iron ore, and specifically that is hematite. So hematite is going to be reduced, and who is going to reduce this iron ore? This iron ore or this hematite is going to be reduced by carbon monoxide. In other words, carbon monoxide is going to reduce iron oxide. Iron oxide is what? That is iron ore, and specifically that is hematite. So hematite is going to be reduced, and who is going to reduce that? Carbon monoxide is going to reduce that. So the carbon monoxide is oxidized. You have studied in your grade 9, the reducing agent is that agent which is going to reduce others, and it oxidizes itself. So reducing agent is what here in stage 3, that is carbon monoxide is reducing agent. So it is going to reduce others and it is going to oxidize itself. So carbon monoxide is going to be oxidized. It will oxidize itself to carbon dioxide. After its oxidation, it will convert into carbon dioxide. And if we talk about hematite or iron ore, that is going to be reduced because of carbon monoxide. So after the reduction of hematite or iron ore, it is going to be converted into the metal. So you have got iron oxide. This is going to be reduced. So what does reduce means? Simply in this example, if clearly, if you want to understand very clearly or simply, you should be understanding the oxidation reduction by removal or addition of oxygen, because that's simple way you can understand. So iron oxide is going to be reduced. So here oxygen should be removed. So if oxygen removes, then it is going to be reduced. So reduction is simply what? That is the removal of oxygen. If Fe2O3 removes oxygen, then it is what? It is going to be reduced. So carbon monoxide is what? It is going to be oxidized. If it is going to be oxidized, so it needs oxygen or it will aid oxygen. It will take oxygen or oxygen is going to be aid in carbon monoxide. Carbon monoxide is going to be oxidized. So the thing that is going to be oxidized, it should gain oxygen or oxygen should aid in carbon monoxide. So once carbon monoxide gains oxygen or any oxygen aids in this, then oxidation occurs. As per your grade 9 definition of oxidation reduction is according to removal or addition of oxygen, you know the removal of oxygen is reduction and addition of oxygen is oxidation. So I will read the comments again. In this redox reaction, carbon monoxide is the reducing agent. Carbon monoxide is reducing agent. It reduces the iron oxide to the metal. So iron ore is going to be reduced and the carbon monoxide itself, it is going to be oxidized to carbon dioxide. So carbon monoxide is what? It is going to be oxidized. So after oxidation, it is going to be converted into what? It is going to be converted into carbon dioxide, this, right? And this one, this is simply going to be reduced. Iron ore is going to be reduced and it will convert into iron, right? This is the process, and these are three stages which we have discussed, right? The first stage was the coke burns, giving off heat. Second stage was carbon monoxide formation. Third is the ore reduction, and the ore is hematite. So that is iron. So what is the limestone for? You should know that whatever reactants you use, as I already told you in the beginning, that we are using three reactants: the limestone, coke, and the iron ore. So you should know those reactants, for what those reactants are used, right? You should know the usage of those reactants. And we have discussed regarding coke, we have discussed regarding iron ore, hematite, but we didn't discuss the usage of limestone. Though we have used that, we have put it there in the furnace, blast furnace, but we didn't discuss about this limestone, that what's the role of limestone. So in this slide we will be discussing the limestone usage or its role in this reaction or in the extraction of iron. So the limestone breaks down in the heat of the furnace. So it is going to be break down in the heat of the furnace. So first of all, this limestone, this is going to be break down into calcium oxide and carbon dioxide. Calcium oxide is in solid state and carbon dioxide is in gaseous form. The calcium oxide, this calcium oxide that forms reacts with sand. This calcium oxide is going to react with sand, and the sand, which is mainly silicon dioxide, right? So silicon dioxide is your sand. So calcium oxide is going to react with silica. And what is silica? That is sand. And what sand? That is silicon dioxide. And this is the formula of silicon dioxide. Once calcium oxide reacts with silica, it's going to form calcium silicate, and the formula is CaSiO3, and it's a solid form. The calcium silicate forms a slag. Calcium silicate, this is basically what you called is slag, which runs down the furnace and floats on the iron. So it's actually which runs down the furnace and floats on the iron, right? So this happens with the limestone. So moving towards the comments of this limestone, the purpose of this reaction is to produce calcium oxide. Why this reaction occurred is because to produce calcium oxide. And since you know that we have calcium oxide here, because of this reaction calcium oxide is formed, so the purpose of this reaction is to produce calcium oxide, which will remove the sand that was present in the ore. So which will remove the sand, right? So why are we producing this calcium oxide? To remove the sand that was present in the ore. So whatever gang present in the ore, right, that is something need to be removed. So this calcium oxide is going to remove the sand that was left over, or that was part of ore, right? So that sand is going to be removed by the calcium oxide. So why are we doing this reaction, this limestone? It's because to produce calcium oxide. And what is the need of calcium oxide? The calcium oxide is going to remove the sand that was present in the ore. So calcium oxide is the basic oxide. Calcium oxide, this is the basic oxide, and silica is an acidic oxide. So what is silica? Do you remember what is silica? Silica is something we discussed, that is sand, which is mainly silicon dioxide. So silicon dioxide, you can refer it as silica. Also, you can name it as silica. To what? To silicon dioxide. So sand is basically mainly, it is mostly silicon dioxide. So silicon dioxide, other name is silica, right? Silica. So calcium oxide is a basic oxide. Calcium oxide that is formed, that is basic oxide, and silica is an acidic oxide. Calcium silicate is salt. So calcium silicate is what? Calcium silicate, it's a salt. So what is calcium silicate? You remember? So calcium silicate is basically the slag. This CaSiO3, calcium silicate. That we say, we usually, you have heard about slag. The formula of this slag is CaSiO3. We call this calcium silicate. So this is slag. So this calcium silicate is a salt. Calcium oxide is basic oxide, and silica is acidic oxide. The molten slag is drained off. You have got the slag, you are going to take it out from blast furnace, from the bottom, right? From the bottom of the furnace, you are going to just take it away. You will drain it out. When it solidifies, it is sold mostly for road building. Slag is like waste material of this extraction of iron process. What? It is a waste product, but it's no more waste when you are going to use it for the building roads, right? So though it is a waste of this product, but it is not going to be waste. You will use that later on. We can say like slag is a byproduct. What? That is a byproduct that is formed in parallel while extracting iron. So it's a byproduct, though it is a waste product, but you will use that later for building roads. So now at the end we will discuss the waste gases, and it's also important which gases are waste gases, which evolve while extracting iron, right? So hot carbon dioxide and nitrogen come out from the top of the furnace. From the top of the furnace, the carbon dioxide and nitrogen are going to be released from the top of furnace. The heat is transferred from them to heat the incoming blast of air, like this. So you should know the gases, the waste gases, the carbon dioxide and nitrogen. These two gases are waste gases, and these are going to evolve from the top of the furnace. And I will read the comments. The carbon dioxide is from the reaction in stage 3. You remember stage 3, there we have produced carbon dioxide. So I will go back to show you the stage 3 here. So here we have produced this carbon dioxide. This carbon dioxide is produced here, and this is the waste of stage 3, right? So in stage 3 we have carbon dioxide, and that is a waste gas, and the nitrogen is from the air blast. It has not taken a part in the reactions, so has not been changed. Nitrogen is from the air blast. So you should remember these reactions, right? So you should remember these reactions and the waste gases, from which stage the waste gas is produced. You should know these all reactions, and specifically you should know the comments. Reactions and comments are very important as per your examination. Where next? So I will move on. Where next? The iron from the blast furnace is called pig iron. Whatever iron you have extracted in your stage 3, that is called pig iron. Pig, pig iron is impure. Pig iron is uh, impure iron. You need pure iron. So carbon and sand are the main impurities. Carbon and sand are the main impurities. Some is run into the molds to make cast iron. This is hard but brittle. Okay, leave it. Leave it. So you should know the name, that is pig iron, that is formed in the blast furnace. The blast furnace, you will take this iron out from the blast furnace, from the bottom. From the bottom you will take out slag and pig iron both, but from different points. Slag will be in different, you will get slag in different point, and that pig iron in different point. So from the bottom both will be collected, and the iron ore is finally converted into pig iron, and this pig iron will be purified as much as possible. Though it contains, this pig iron contains mostly iron, but still it has got some impurities. You will work on this and you will purify this pig iron, and you will make the iron, this pig iron, to iron, to pure iron I should say, to pure iron as much as possible. You will make it pure. So from now onwards, whatever we have studied and whatever we have not studied, maybe you will have a lot of information. You should read it for yourself. I have jotted down these all points from Sindh book, because it was recommended by Akhan Examination Board. It has recommended to use this Sindh book as a reference, right? So for chemical industries, specifically for the extractions, right? Extraction of iron, copper, aluminum, whatever extractions are part of our SLO. For those extractions, we can use a Sindh book as a reference. So these points you should read, and I'm not going to read these points. I have a lot of information. From now onwards, I'm not going to read it or make you understand any point, but whatever I have done till now, that's very enough. And I recommend and I suggest you to read these points. Pause the video and read each slide. And at the end, what we are going to do is like we are going to give you a summarization. We will summarize at the end, right? We are going to summarize all these points at the end, uh, and we will be discussing some MCQs. I will show you some MCQs which are asked in past examination related to this SLO. So whatever knowledge you gain, this all knowledge is like authentic knowledge you are getting, because I have collected this all content from authentic sources and from recommended books of a QEB and from recommended reference books of a QB and recommended websites and this is it about description of extraction of iron, and this is pro review step by step. This is very important, so you should read this, and you should write down it in your notebooks, right? Because these are steps which we have discussed, and these are pro review step by step points of extraction of iron. So sample questions, we have this: a blast furnace is charged with hematite or coke and limestone from the top. It is then heated by blowing hot air in it from the base. Using the given information, describe the stages that enable the extraction of iron from its ore. Write chemical equations to support your answer. Very simple. Whatever steps we have discussed, these steps, right? These steps, if you write these steps with its chemical reactions, you will get 7 out of 7, right? You will get 7 out of 7. So the next sample question is the diagram below shows a blast furnace used for the extraction of iron. Several reactions take place inside the blast furnace. Once the charge is loaded, this leads to the production of liquid iron. And what is charge? We have discussed the charge, that is iron ore, the coke and limestone, collectively called charge. Once you loaded the charge, this leads to the production of liquid iron, and we have already discussed this. Liquid iron is formed in the stage 3, right, if you remember. So ABC, charge is a mixture of 3 raw materials, 2 of which are iron ore and limestone. Name the third one. Very simple. Name the third one. And the second is describe the extraction of iron. One of the reactions produces carbon monoxide. Write a balanced chemical equation for this reaction. During the extraction of iron, one of the reactions produces carbon monoxide. You have got 3 reactions, right? One of the reaction is going to produce carbon monoxide. You have to write the reaction. Simple, very simple. That reaction is stage 2 reaction in which carbon monoxide was formed. Very simple. The third is a molten slag floats on top of the molten iron at the bottom of the furnace. How is this slag formed and what are its constituents? Okay, how is this slag formed and what are its constituents? That is because of limestone, right? Slag was formed from limestone. We discussed this in while studying the limestone, and we were studying like why limestone was put it into the furnace, and we had discussed the limestone, and during that discussion we have studied that slag was formed by the calcium oxide, sorry, the first of all, limestone was broken down into calcium oxide and carbon dioxide. So calcium oxide, it reacted with SiO2, that is sand, or after that this slag is formed, CaSiO3, this is slag. So these are, you have to write this reaction as well as the constituents, and you have this very simple thing you have to do. This is very simple, and this is how you are getting full marks, right? You have to study very deep. Please do not leave the rest of the content we have shared. Please read that, right? If you couldn't understand anything in that, just discuss with your teacher, because it's very important. Please, I urge you to do that. Moving towards MCQs, very simple MCQs. Maybe describe the extraction of iron. During the extraction of iron in a blast furnace, the hematite ore is that's what I said in comments. I was mentioning again and again that the comments are important because we have discussed these things in comments, right? While studying stages, we had also mentioned some comments regarding those stages, and those comments are very important with reference to MCQs. During the extraction of iron in the blast furnace, the hematite ore is going to be reduced, oxidized, hydrated, neutralized, and we know C and D cannot be the options. Only reduced or oxidized can be options, because all the reactions happening in the blast furnace are redox reactions, and the reduced or oxidized can be the option. Any one from A, B can be the option. You have to find out and let me know in the comment section. And second is the impurities of iron ore are removed by. Impurities of iron ore are removed by. How do you remove the impurities of iron ore? We have discussed this, and also whatever content I've shared later which I didn't discuss, just I ask you to read that. In that content you will find clearly the impurities of iron ore removal, right? You will find reactions and you will find the content how the impurities of iron ore are removed. Though we discussed this, but in later content which I didn't discuss, in that content you will find clearly. And I think one slide is for this impurities of iron ore removal. So the third is, which of the following products is obtained when carbon monoxide reacts with iron oxide? Which of the following products is obtained? Which of the following products obtained when carbon monoxide reacts with hematite? Iron oxide is basically hematite in the blast furnace. So this is related to one of the stage, right? We have discussed three stages, and if you know the stages, if you know the chemical reactions, if you know the what is going, which is going to be reduced, which is going to be oxidized, you can answer everything. In lecture 4 we are going to do the differentiate between iron and steel, and further rules will be covered in later lectures. And if you like this video, and if you think this helped you, hit the like button and please drop your feedbacks in the comment section. We love your feedbacks and we work on your feedbacks, and we will love to have your feedbacks in the comment section. TTV signing out. Tatai. Thank you very much.